Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome back, my students, on engineering basics. So today we are going to do our first meeting. So this is our first meeting, and I think I don't have to introduce myself because I think you are already familiar with me, since I was your lecturer for basic physics, and now it's time for me to be your lecturer again, But today the course will be engineering physics, Okay, and for engineering physics, the duration will be 2 credit point, or in bahasa Indonesia we usually say it with 2 SKS, SKS means credit point, and for credit points and for 2 credit points, the duration will be like 100 minutes, 100 minutes. So I will be always start this course from 9:50, and I will end at 11:30, because we have to do Jum'ah prayer, karena ada sholat Jumat, jadi maksimal 11:30, And if you have any question, regarding the material or everything related to this course, you can just raise your hand or you can ask me via the chat box, Jadi kalau ada pertanyaan bisa angkat tangan atau bisa menuliskan di kolom komentar, Okay, so I hope my voice is clear, because I already checked it using my smartphone, and I think I don't get any problem with my voice. Okay, and then let's start. Let's start our course today with basmalah. Bismillahirrahmanirrahim. Okay, let me make it faster. On the schedule, our course will be end at this time, but I think I will make it faster, so you can have more time to prepare for Friday prayer, or Salat Jumat, Okay. So what is the difference between engineering basic physics and engineering physics, Okay, so we have basic physics, on our first semester, and then the second semester we have engineering physics, Okay, so in basic physics, we focus only on mechanics, mechanics, mechanics is like when you have a box, and then the box is pushed by a certain force, then the box will move with certain velocity and also acceleration, Or let's say you have a ball, and then you throw up, and then we are going to find the highest point of the ball, and then after we get the highest point of the ball, then we try to find the duration, the duration from this point into this point, or let's say you have a ball here, and then you throw it with certain angle, we have angle here, Then you try to find how long the distance from the point A to point B, because the ball will have parabolic motion, the motion will be like this, the motion will be like this, okay. So it's mechanic, but in engineering physics, we are going to deal with not only mechanics, with not only mechanics, and I think in the engineering physics, we are going to deal with something that cannot be touched, something that cannot be touched, or even if we can touch it, then it will be harder, because in mechanics, we are usually dealing with solid material, solid material. Jadi bendanya padat, jadi bisa apa namanya, bisa dipegang gitu, we can touch the material because it's solid, it's easy for us to touch, to touch the object, but in engineering physics, we are going to deal with fluid, fluid, in fluid we have liquid and also gas, Nah, liquid or in bahasa Indonesia itu artinya cair, kalau gas gas, okay. And then also in engineering physics we are going to deal with heat, atau panas, and then also heat transfer, heat is something that cannot be touched, we cannot touch the heat, but we can feel it, so we can feel it, but we cannot touch it, but we can feel it, so we are going to deal with something that can be feel but cannot be touched, so I think it will be challenging for us, also we are going to deal with electric current, electric current, or electricity, electricity, physics that deal with electricity, also electricity cannot be touched, but we can feel it, we can feel it through our smartphone, because our smartphone can active because it has energy from battery, and battery is some kind of electricity source, also your lamp, maybe you are now in your room, you can feel the light, you can feel the light from your lamp, and the lamp can be brightful, because there is electricity that can make the lamp bright, jadi ada listrik, listrik tidak bisa dirasakan, tidak bisa dipegang, tapi kehadirannya bisa dirasakan, dari lampu, dari laptop, dari HP dan sebagainya. And this is that we are going to deal, we have fluid, we have also heat, and then we have also electric current, okay. And now about the book, about the book that we are going to use, okay. The book for our class, we are going to use this book, so Essential University Physics, this book I'm going to distribute this book to Schoology, so please don't be worried, don't be worried, because you will get the PDF of this book, Essential University Physics, okay. And I will distribute the book on Schoology, ya, on the Schoology. So please don't forget to join, ya. Don't forget to join to the Schoology, because everything, yeah, every material, every homework, yeah, will be distributed on the Schoology, yeah. And also, please don't be forget, because the offline class, yeah, the offline class will be started at 28th March, yeah. Please prepare yourself, yeah. But if you have still problem attending the class at this date, yeah, please you can contact Pak Wijianto, ya, Pak Wijianto, ya, as the person in charge for international class, yeah. And please you can ask to Pak Wijianto if you have any problem, yeah, attending the class offline in this date, yeah. Because actually I don't have any problem if you still want, yeah, to do the class online for one or full for this semester. I don't have any problem with that. But actually for the mid test, yeah, but for the mid and also final test, yeah, you have to do it, yeah, you have to do it online, offline, yeah. I don't have I don't know whether you can do your test online or not, yeah. So please you can confirm Pak Wijianto, yeah, or Mr. Wijianto first, so you can have clear information about the offline class, yeah. Okay, but in regular class, the offline class will be started at this date, yeah. But I don't know for the international program, yeah. Okay, so yeah, and now let's check the Schoology. The Schoology. Oh, I'm so sorry. Okay, so this is the Schoology room for our class, yeah, for international class. So please ensure yourself you have already joined into this one, yeah, physical technique or engineering physics 2021 2, yeah, 2 means second semester, yeah, international class, yeah. And this is the access code, so I will distribute the access code into the chat room, yeah. So please join through the code that I already distribute to all of you, yeah. So the members that already joined into this, okay, so yeah, it's only 2, yeah. So far it's only 2 person. So we have Mas Muhammad Fadlan and also Mas Aji Ahmad Fahludin. So thank you very much to join, to already join to this Schoology in early time. But so please for everyone, yeah, because I see there are 5 students here, 5 students that join into this course, yeah, so far. So please ensure yourself to this group, yeah, because all of your homework and also presents will be recorded in this Schoology room, yeah. Okay, and if you have any question or problem regarding joining this Schoology room, so please you can contact me personally, yeah, you can contact me personally. Okay, Okay, so before I start for the course today, so do you have any question or not? So you can just raise your hand or type your question on the chat room. Okay. Okay. Okay, I think there are no any questions. Okay, so I will start my course today. Okay, so because we have so limited time, yeah. Okay, so this course, yeah, our class today will be recorded, yeah, and I will distribute this record on the school, okay, yeah. And also, if you have any problem with my English, yeah, because I have to admit that my English is not so clear to be understood. So I also will be distributed the Indonesian version of this course, yeah, because in regular class I have also my own class, and it is delivered in Bahasa Indonesia. So if you have any problem with my English in this class, you can just try to watch, yeah, the record of my class for the regular program, yeah. Okay, so you can check from the books later, yeah, later on after I distribute the book, and we start from chapter number 15, yeah. So the chapter number 15 will be our first meeting, yeah, first meeting. Okay. Okay, so we are going to talk about fluid, yeah. Nah, if we talk about phase of material, atau in bahasa Indonesia it's called it fase benda, yeah. We have commonly, yeah, we have common phase in our Earth, yeah, in Earth, I mean, yeah, because the object of our observation is only on the Earth, yeah, and this can be different if we have access to observe the physics in other planets, yeah. But I think we can still reach that on the future, in far future, yeah. But now we can just focus ourselves on observation in our Earth, yeah, in the planet that now we are living now, yeah. The first one we have solid, yeah, or padat, and then we have liquid or tire, and then also we have gas, yeah, or gas in bahasa Indonesia, yeah. And fluid, yeah, fluid is these two materials, yeah. Okay, so liquid and all good, I mean fluid, yeah. Fluid, yeah. Okay, so fluid, yeah, is liquid and gas, yeah, but solid is not fluid, yeah. So I think this I think you can understand, yeah, what I mean, because solid is only solid, but for fluid, yeah, is consists of liquid and gas, yeah. Nah, example of some example of fluid, yeah. We have water, yeah, or H2O, and then also we have oil, yeah, and then also we have a lot of things, yeah, actually, yeah, water and then oil, and then your blood, yeah, your blood is also fluid, yeah, and then etc. Yeah, I think you know, yeah, you know what kind of fluid in our daily life, yeah. Okay, and now what is the characteristic of fluid, yeah? Okay, so what is the characteristic of fluid, yeah? Nah, the characteristic of fluid is this word, yeah, this word, yeah. So flows, yeah. So what is flows, yeah? So what is flows, yeah? Flows mean flow, ya, actually, ya. Flow means mengalir, ya. So we can consider a material is fluid or not, yeah. If the material can flow, it means it is fluid, yeah, fluid, yeah. But if we know something, yeah, or an object and it doesn't have any capability of flowing, yeah, or cannot flow, so we can just make it simple, the object is not fluid, ya. Jadi kalau ada material, ya, atau benda yang dia tidak bisa mengalir, itu dia berarti bukan fluid, bukan fluida, ya. Jadi contohnya let's say, ya, example that can be flow is water, ya. Water, ya, the water can flow, ya, so it means fluid, ya, karena air kan bisa mengalir, ya. But let's say marble, ya, marble means kelereng, ya, kelereng cannot flow, ya, dia tidak bisa mengalir, ya. So marble is not fluid, ya, marble is not fluid, ya, because it cannot flow, ya. Nah, jadi gitu, ya. Jadi kalau ada benda yang dia tidak cocok, ya, kelereng itu bisa bergerak gitu, ya. Tapi kan aneh kalau mengatakan kelerengnya mengalir. Nah, itu kan aneh, ya. Jadi we can know that marble can move. Yes, we know marble can move. Let's say it is a marble here, and we put force here, external force. So the marble will move, yeah, with certain velocity or certain acceleration. But marble is not flowing, ya. Jadi kelerengnya tidak mengalir, tapi dia bergerak, ya, sehingga dia tidak non fluid, ya. But if water or oil, ya, we give external force on it, then the water will move, and the movement of the water is called flowing, ya. Jadi gerakan dari air itu mengalir, ya. Air mengalir, gas mengalir, gitu, ya. Minyak mengalir dan sebagainya. Jadi itulah yang menjadi dasar secara mudah membedakan antara fluida dan bukan fluida, ya. Actually, there are some ways. Yeah. I mean, there are other ways. There is another way to differentiate between fluid or not fluid, ya. Jadi ada cara lain untuk ngecek apakah dia fluida atau bukan, ya. But we have to deal with atomic structure, ya, and I think it will be more complex. Yeah, so I will not give it to you right now because I think those concept, yeah, the concept will be given to you on the higher semester ya. Jadi melihat perbedaan antara fluida dan non fluida dari kapasitas atau dari perspektif susunan atom, ya itu nanti akan diajarkan nanti ya. Jadi yang sekarang kita simple dulu aja ya. So we try to simplify the understanding of fluid and non-fluid. Yeah. Okay. So this is the definition of the definition of fluid. Yeah. Okay. Okay. Now we are going to talk about density and also pressure. Yeah. But before I continue my explanation, maybe you have any question, so you can just ask me. Yeah. So density and pressure after this. Yeah. Okay. Okay. So no question. Yeah. For definition of fluid. Now I'm going to continue my explanation on density. Yeah. In bahasa Indonesia, density means massa jenis. Yeah. Okay. So what is density actually? Yeah. So the symbol of density is rho. Yeah. So this one. Yeah. The symbol of density is rho. Yeah. Rho. Yeah. And then rho is mass of material divided by its volume. Yeah. Nah, the unit of mass is kilogram, and the unit of volume is meter cube. Yeah. And this unit is in international standard. Yeah. So mass divided by volume. Yeah. So the units of density, yeah, is kilogram per meter cube. Yeah, kilogram per meter cube. Yeah, kilogram is for mass. Yeah, for the mass. Yeah, atau massa. And then the meter cube is for the volume. Yeah. Okay. So this is the unit of density. Yeah. Okay. Okay. So this one is okay. So density is rho, not P ya, but rho ya. Mass divided by volume ya. The unit is kilogram per meter cube ya. This one is SI ya, or standard international ya, or international standard of the unit ya. Or also sometimes people also use gram per centimeter cube ya, but it's not non international standard ya. Okay. And density can be used to characterize certain material. Nah, Density can be used to characterize certain material. Ya, maksudnya gimana ya? What does it mean, gitu ya? Jadi massa jenis itu bisa digunakan untuk mengetahui apakah material itu benar-benar material yang dimaksud, gitu ya. So using the density concept, we can characterize, ya, we can characterize the material, ya. The material is real or pure, certain material, or it is not, ya. So as example, density of gold, let's say, ya, because gold is a precise metal, yeah, and people only want to get the pure gold, yeah, because gold is very precise, yeah. I mean, not precise, but priceful, yeah, priceful metal, yeah, and sometimes gold is also used for financial system, ya. Jadi emas itu kan maunya orang-orang ya yang murni, ya tidak ada campuran lainnya. Ya. So the density of gold is, let's find it, density of gold, ya, density of gold. Yeah. Okay, the density of gold is around, let's say in the image, gold. Okay, so gold is 19.3. Yeah, 19.3 gram centimeter cube. Yeah, or if we convert it into SI, then we are going to get 19,300 kilogram per meter cube. Yeah. So the density of pure gold will always this one, yeah, or this one. Yeah. If you have uh, if you have uh, 1 centimeter cube of gold, yeah, then the mass will be 19.3 gram. Yeah. Yeah. So this one can be used to identify, yeah, the gold is pure or not. Yeah. Because when you have 1 centimeter cube of gold, yeah, but the mass is not this number, it can be you can unsure that your gold is not pure. Yeah. Yeah, so you have to be careful, yeah, when you buy gold, yeah, because sometimes the seller can scam on you, ya. Jadi bisa ditipu gitu ya. So that's why the concept, the understanding of density concept is very important, ya. Yeah, because it can be used to identify the purity of certain material. Yeah. Okay, so this one is a concept of density. Yeah. So you have mass and then divided by the volume. Yeah. So I think it's simple things, yeah, to be understood. Okay. Now we go to the next one. We have pressure. Yeah. We have pressure. So in bahasa Indonesia, pressure mean tekanan. Yeah. Okay. So what is pressure? Yeah. So mathematically speaking, yeah. So this one is pressure. So pressure or P, yeah. P is force divided by A. Yeah, force divided by A. Yeah. Force divided by A. Yeah. So F is for the force, ya, atau gaya in bahasa Indonesia, and the unit is Newton, ya. And then A is area or luas. and the unit is meter square, yeah, or meter to the power of 2, yeah. Okay, so the unit of pressure, yeah, the unit of pressure is F divided by A, yeah. The uh, the the unit of F is Newton, and then the unit of area is, so this one is the unit of pressure, yeah. Okay, but sometimes, yeah, sometimes, not sometimes, yeah, but people usually use, yeah, people usually use PA or Pascal, yeah, as unit of pressure, yeah, yeah, and 1 PA equals to 1 Newton per meter square, yeah. So actually, it's similar, yeah. So PA is similar with Newton per meter cube, yes, per meter square, yeah. So you don't have to be confused, yeah, when you find people talking with Pascal as unit of pressure, yeah. Meanwhile, you use Newton per meter square, yeah, to indicate the unit of pressure, yeah, because actually PA or Pascal is equal to Newton per meter square, yeah. Okay, so this is the unit of pressure, yeah. So as example, yeah, example, um, how much pressure of um, of an object with mass of 15 kilogram, yeah, standing on two, not two, yeah, but I say 10 5 centimeter square area, yeah. Okay, because we are going to find the pressure, so the answer is P equals to force divided by A, yeah, and the force is gravitational force, yeah. It must be W, yeah. W means mass times by G, yeah, because we only have mass here, not the force, yeah. So the mass is 15 kilogram, 15 kilogram, and then the gravitational force, for the simple one, we choose 10 meter per second square, yeah. So the mass 15 times by the gravitational acceleration, so it must be 10, yeah. So the force will be, the force must be 150 Newton, yeah. So we already get the force, yeah. And now how about the area, yeah? So the area is 10 times 5, yeah. So it must be 50 centimeter square, yeah. But the square is not international standard unit, yeah. So we have to convert it into the standard one. So we have to convert into meter square, yeah. Okay, so meter square means 50 times 10 to the power of minus 4, yeah, minus 4 centimeter, decimeter, and then meter, yeah, minus 4. So it must be 5 times 10 to the power of 3 meter square, yeah. Okay, we already get the force, and also we have the area value. So the pressure must be F, yeah, the force 150 Newton divided by this one, yeah. Okay, and you can use your calculator to find this one divided by this one, yeah, and you get something Pascal, yeah. Okay, so this one is for the example of calculating, yeah, the calculating pressure, yeah, of an object with mass 50 kilograms standing on this one area. Okay, yeah. So and then let's continue what we have. Yeah. So now we are going to learn about the hydrostatic pressure, yeah, hydrostatic pressure. Okay, but before I explain the hydrostatic pressure, if you have any question, so please ask me, or you can just type your question, yeah. Okay, I think so far so good, yeah. No any question. So let's start with the hydrostatic pressure, yeah. So let's say you go to swim, yeah. You go for swimming. Let's say, okay, you go to swim, and then there are two pool here, yeah. The first one is A pool, and then the other one is the B pool, yeah. Okay, and then I will draw, yeah, and this is the water, and then this one is the motor, yeah, and the depth, yeah, the depth of the A pool is, let's say, 2 meters. Meanwhile, the depth of the second pool is 5 meter. Okay, now, yeah, we can use our intuition, yeah, or we can use our logic. Now, if I ask you, yeah, if I ask you which one, yeah, uh, no. Okay, and then you swim, ya, you dive into the floor of the pool, ya. Jadi kita menyelam gitu ya, menyelam ke dalam dasar, menyelam ke dasar kolamnya, ya. So let's say I'm here, and then also I try to the B pool on this one. Nah, okay, so which one, ya? which one is the not which, yeah, but actually where is the bigger pressure, yeah, on the A floor or B, yeah, on the B floor, yeah? If I ask you this question, yeah, then the answer will be this one, yeah. The answer will be the B floor, yeah. The reason is because the depth of the B floor, yeah, is bigger, yeah, is bigger than the depth of my position when I am on the floor of a pool, yeah. Okay, so this phenomenon is an example of hydrostatic pressure, ya. Jadi kita merasa berat ketika menyelam, ya, dalam air. Semakin dalam kita menyelam, para tekanan yang kita rasakan itu semakin besar, ya. Nah, jadi tekanan itu adalah tekanan hidrostatis, ya. Okay, so that is the simple understanding of the hydrostatic pressure, ya. But now we have to apply it, ya, using a mathematical approach, ya. Jadi kalau perasaan kan seperti itu, ya, lebih besar, ya. Tapi besarnya seberapa, ya, itu memang harus dihitung, ya, sebagai pertimbangan kita ketika kita mendesain sebuah konstruksi yang dipasang pada kedalaman air, gitu, ya. Yeah, so we have to try to translate, yeah, our logic into number, yeah. So we have to apply some formula, yeah. So people can not only know that, oh yeah, higher depth, yeah, will consequence on a higher pressure, yeah, but people do not know how much it is, yeah. So that's why we have to put the calculation through mathematical approach, yeah. Okay, now formula for hydrostatic, yeah. Formula for hydrostatic pressure, yeah. Okay, so if we take a look on this book, yeah, so this one is the formula, yeah. So I'll put it here, P and then PO plus rho GH, yeah. The P here is total pressure, yeah, in Pascal, and then PO is atmospheric pressure, yeah, also in Pascal, and then rho is the density of fluid, yeah. Density of fluid is in kilogram meter cube, and then the G is gravitational acceleration in meter per second square. Then the last one is the H, yeah, or the depth, yeah, in meter, yeah. Okay. Okay, yeah. Now let's say I have a tank here ya, punya tangki di sini ya, and then I fill the tank with water ya. Let's say the fluid for our case now is water ya, so this one is water ya. Nah, and then I put an object into this water. Yeah, let's say the object is a ball here. Nah, okay. Nah, between the surface of the water to the object, yeah, there is something called with edge, yeah, or depth, yeah, and the depth will be different if the object. Let's say I have another object here. Let's say I have an object here, and then the object of second on the green ball will be start from the surface of the material and the surface of the fluid to the position of the green ball. Yeah, so the green one is also h, but the value of h here and the value of h here is different ya. Jadi tergantung lokasi bendanya ya. Kalau bendanya yang tadi berwarna ungu, dia kedalamannya ada di sini nih. Ya, kedalamannya ada di sini ya. Nah, tapi kalau bendanya yang hijau, dia kedalamannya ada di sini ya. Dari titik sini ke bawah sini ya. Okay, so it depends on the position. Yeah, the depth of the ball will be different. Yeah, because it has a different position. Yeah, from the surface of the fluid. Yeah, in this case we use water. Yeah, and then okay, I got question from Wesley. Just for the confirmation, sir, which value do we use for G? Yeah, is it 10 or 9.8? Yeah, actually, the most precise, the most precise is 9.81. Yeah, that's the most precise. Yeah, but sometimes for the simplification of calculation, people use only 10. Yeah, only 10. Yeah, or only 9.8. Yeah, but actually, you have to pay attention with the problem. Yeah, sometimes in the problem, let's say you have a test for you, and then on the test it is mentioned that the value of G is 10. Yeah, you have to follow the rule. Yeah, you have to follow the rule. You have to follow, it must be 10. Yeah, but sometimes if if you have a problem and there is no any information, you can use whatever you want. Yeah, you can use 10 or 9.8 or 9.81. Yeah, but actually it's up to you. Yeah, it's up to you. Yeah, meanwhile you are still in a university, you can use every number. Yeah, every number. Yeah, 10, 9.8 or 9.81. Yeah, but actually in real case, people will always say you have to use 9.81. Yeah. So I think it's a it's a good question. Yeah, but you don't have to be worried. Yeah, what kind of number you can use. Yeah, just use the most simple one. Yeah, just use the most simple one. Yeah, the simplest one. Unless you have to use certain value of gravitational acceleration. Okay, thanks Wesley for your question. Okay, so now we can continue to this one. This one is H, and then this fluid has the density. Yeah, the density of water will be different with the density of oil. Yeah, so you have to pay attention. Yeah, and the information of density will be given when you have to solve a problem, yeah. And then the G, yeah, the G is the gravitational acceleration, yeah. I think you have familiar with this. And then the PO, yeah. I will use, and then this one is PO, yeah. The PO is atmospheric pressure, yeah. The value of atmospheric pressure, you can find it on Google actually, yeah. Uh, in Pascal, yeah. Please, yeah, you have to in Pascal, yeah. Okay, so the standard atmosphere mean PO, yeah. So PO mean also standard atmospheric standard atmosphere, yeah. Standard atmosphere, yeah. The value is this one, yeah. 1,325 Pascal, yeah. Or this one is also 1 atmosphere, yeah. 1 ATM, yeah. But ATM is not international standard, yeah. So you have to please, yeah, change. You have to convert everything into international standard first, yeah. And then after you do your calculation, then you can change back. You can change back your final value into the unit that the problem wants, yeah. Okay, but please pay attention. Before you do your calculation, you have to always, yeah, you have to always convert it into international standard, yeah. You have to go into meter, yeah, or into Pascal, yeah, etc., yeah. So this one like this, yeah. Okay, so if I have example, yeah, maybe, yeah, example. So let's say I have a container here. Container, and then I fill it with let's say I will fill it with oil, yeah. So it's oil, and then I put an object on this position, and this position is let's say 15 centimeter, yeah. And then the density of oil is, that's fine. The density of oil, density of oil. Let's say olive oil, yeah, because we have a lot of kind of oil. So let's say in this one, olive oil, yeah. The olive oil is 0.9, that in gram centimeter cube, yeah, gram centimeter cube. So we have to convert it into kilogram per meter cube, yeah. So we can we can multiply it by 1,000, yeah. So it will be like this, kilogram per meter cube, yeah. So it's the density of oil. And then for our simplicity, so I will put G is 10, yeah. Yeah. Yeah, for this case, I will use 10, yeah. And then the atmospheric pressure is 1 ATM, yeah. But ATM is not international standard, so I will change into Pascal first, yeah. The Pascal will be 101,3 to 5, yeah. Yeah, 3 to 5. Pascal. Yeah. Okay. Now the question is the total pressure of this ball. Yeah. The total pressure. Okay. How much total pressure of the ball, of the green ball. So the green ball, yeah. Okay, so it will be P, yeah, PO plus rho GH, yeah. The PO is 101,325 Pascal plus the row of olive oil is 900, and then times the G is 10 here, and then times by this one is 15 centimeter, so I have to convert it into meter, so it must be 0.15 meter, yeah, 0.15, and you will get the answer, yeah. You can use your calculator, yeah. 101,325 plus 900 times 10 times 0.15, and then you plus the two values, and you'll get the total pressure that filled, yeah, that filled by the green ball, yeah. So this one is the green ball, the object that we try to identify, yeah. Okay, yeah. So this one is for the hydrostatic pressure. Okay. Okay. So and then there is a example here also, yeah. The example is about two questions, yeah. The question A and also question B. For the question A, at what water depth is the pressure twice atmospheric pressure, ya. Ini maksudnya adalah pada kedalaman berapa kira-kira tekanannya itu 2 kali lipat tekanan normal gitu ya. So it must be 2 atm ya. Nah, at what depth of water the pressure will be twice compared to the pressure at the normal condition, yeah. And the answer is 10 meter, yeah. So whenever you dive, yeah, into 10 meter below the surface, below the water surface, then you will feel 2 times of normal atmospheric pressure, ya. Jadi kalau renang dengan kedalaman 10 meter, ya, itu kita akan merasakan tekanan 2 kali lipat, ya. Tekanan 2 kali lipat jika dibanding dengan kondisi normal, ya. So 10 meter equals to 2 atmosphere, ya. And if you go deeper, for 20 meter, then you will feel 3 atmosphere, ya. And then you go again 40 meter, then your body will feel like 4 atmosphere, yeah. Okay, and for the calculation you can just check it by yourself, yeah. And then the second question is about what is the pressure at the bottom of 11 kilometers depth Marianas Trench, the deepest point in the ocean, ya. Jadi ini pertanyaannya adalah kalau di dasar palung Mariana, ya, yang mana merupakan titik terendah dasar lautan saat ini yang sudah diketahui, ya, karena bisa saja ditemukan palung yang lebih dalam, ya, tapi sekarang baru 11 km. Nah, 11 km itu tekanannya berapa, gitu ya. So when you have, ya, let's say you put yourself into a submarine, into submarine, and the submarine go dive into 11 kilometers into the deepest point of the ocean, in Mariana Trench, then you will feel this one, yeah, 110, yeah, megapascal, yeah, or 100,000 million, yeah, million pascal, yeah. So 110 million pascal, yeah. And if we convert it into atmospheric, yeah, 110, 1, 2, 3, 4, 5, 6, yeah. And this one, yeah, you will feel 100 times of our more than 100, more than 1,000 times, yeah, of normal pressure in our atmosphere, yeah. So it will be like 100, 1,085 atmosphere, yeah. So can you imagine, yeah, if you dive without any preparation, yeah, then your body will be crushed, ya. Tubuh akan remuk, ya. Tubuh kita akan hancur because we are going to feel more than 1,000 times of normal atmosphere, ya. Okay, so yeah, and for the calculation you can just check it by yourself, ya. Okay, now we are going to measure, yeah. So we have already know the concept of pressure, and then we know how to calculate it, and now we are going to find, or we are going to understand what kind of what kind of uh, tools, yeah, to use to um, measure, yeah, the pressure, yeah. Okay, but before I continue my explanation, maybe you have any question first. The measuring pressure will be the last part of our meeting today, yeah? Because you have to prepare to Jumu'ah prayer, yeah. Okay. Okay, so no question so far. I'll continue the explanation about uh, measuring pressure, yeah. Okay. I'm trying to go fast, yeah, to go fast. In this book, yeah, there are two simple ways, yeah, two simple ways to measure the pressure, yeah. The first one is the first one, uh, the tools, yeah, we call it with barometer, and then the second one is called manometer, yeah. Okay, so yeah, manometer. The first one we are going to learn about the principle of barometer, yeah. Okay, so in barometer, we use mercury, yeah. Or in bahasa Indonesia it is called with air raksa, yeah. Okay, so mercury is like this, yeah. Uh, nah, this one is mercury, yeah. Okay, so let's say I have small container here atau ember atau apalah gitu ya. And then I also have tube here. Now I have tube here, and then I have marking point here, yeah, marking point here, and then I put the mercury, yeah, the mercury into this position, yeah. This is the mercury, or Hg, yeah. Hg is the name in the how to say periodic table, yeah. The iron is Fa, yeah, and then the oxygen is O, yeah. Hydrogen is H, yeah. Then the mercury is Hg, yeah. Hg means hygrarium, yeah. Hygrarium. Yeah. Okay. Hygrarium, yeah. Hg, yeah. Okay. And then I make the tube, yeah, into a vacuum condition, yeah. So I have to ensure that there is no any trapped gas inside this tube, ya. Jadi saya harus memastikan bahwa tidak ada udara yang terperangkap pada bagian yang menonjol ke atas ini, ya. Jadi saya sedotlah udaranya terlebih dahulu sehingga vakum, ya. So in this tube it must be vacuum, ya. Okay. And okay, and then also the position, yeah, also the position of the tube, yeah, must be above the floor of the container, yeah. So you cannot make, yeah, you cannot make the end of this tube contact with the floor of the mercury of the container, ya. Jadi jangan sampai ujung moncongnya ini, ya, dia menempel pada dasar. Jadi dibuat ada celahnya, ya. So there is space, ya, between the floor of the container and the end of the tube, ya. Okay. And then the pressure, ya, the pressure, atmospheric pressure. So we put this, ya, these tools inside outside our room, ya. Jadi dibawa keluar, ya, dibawa keluar. Nah, di luar pasti kan ada tekanan udara, ya. Okay, so we have so there are pressure, ya, atmospheric pressure, ya. Jadi ada tekanan atmosfer, ya. So the atmospheric pressure will push the mercury, yeah, and then the mercury will fill into the tube, yeah, will fill into the tube, yeah, will fill into the tube and fill the tube until certain position, let's say in this position, yeah. Nah, until in this position. Nah, surprisingly, yeah, if you try this one, yeah, this tools in every position in the earth, yeah, but in the normal condition of atmosphere, yeah, the normal condition of atmosphere is in the surface of water ya. Jadi tekanan normal itu terjadi di atas permukaan air ya. So let's say you put these tools on the beach ya. Jadi dibawa ke pantai alat ini. Then the amount of the mercury will always reach into the same position ya. Jadi isinya itu selalu sama ketinggiannya ya. Ketinggiannya selalu sama ya. And the value of this height is 76 mm ya. Jadi kalau tabung ini dibawa kemana-mana ya, ketinggian daripada air raksa itu akan selalu tetap 76 mm ya, asalkan pada kondisi atmosfer pressure-nya ya, tekanan atmosfernya adalah 1 atm ya, atau 101.325 Pascal ya. So when the condition of atmospheric pressure is in normal condition or in 1 atm, the mercury the mercury will always fill into this height in 76 mm ya. So that's why if you make the tool like this and the mercury fill into this height into 76 mm, then it must be the atmospheric pressure or the pressure around the tool is 1 atm ya. Nah, is 1 atm ya. Sometimes people put Hg in here ya. So 76 mm Hg equals to 1 atm ya. Okay, now let's check it on the internet ya. Nah, millimeter of mercury ya. Oh, 76. Oh ya. Okay, 76 760 ya, I mean ya. Millimeter of Hygarium ya. But if we use centimeter ya. Nah, I will put 76 ya. Okay. Okay, 760 millimeter of mercury equals to 1 atmosphere. If I make it double, 2 atmosphere, then the millimeter, then the mercury will have 1520 millimeter of mercury. So this one is 2 times of 760. Or if I put 1.5, then it will be 380. This one is half value of 760. Okay. So this is the mechanism of barometer. So I think this one is a very simple mechanism. It's a simple tool. It's a simple mechanism. But it can help a lot of people. Because this one can be used to measure your surrounding atmosphere. Your surrounding atmosphere. Okay. It's very, very simple. Okay. So this one is barometer. And then the other one is manometer. So manometer is like this. So let's say you have a container here filled with a certain gas. And then you have this one. You have pipe here. Okay, you have pipe here. And then this you fill with gas here. Let's say this gas is P P gas. I mean the gas has pressure Jadi di dalam container itu ada gasnya, dan gasnya punya tekanan gitu ya. Okay, and then in this pipe I will put a fluid, yeah. Let's say I will put water here. So the blue one indicates water. Okay. Nah, the gas will push. Yeah, the gas will push the water. Yeah. So this one will push, yeah, the water, yeah, because the P gas is higher than the PO. Yeah. The PO is also, yeah, the PO is also push the gas. Yeah. Push the fluid. Yeah. Push the water. But because the atmospheric pressure is not higher than the P gas, yeah, so the gas will push the water here, yeah. Nah, because the gas is push the water, so the water will have a different height between the right and also the left pipe, ya. Jadi karena dia terdesak, maka ada perbedaan tinggi, ya, perbedaan tinggi antara air yang ada di sebelah kiri pipa ini dan air yang ada di sebelah kanan pipa ini, ya. Okay, so there is H here. Yeah. Now, how to find the value of the P gas? The value of the P gas. Okay, so this one is P water. Yeah, let's say P water. Yeah. So the P gas. Yeah, the value of P gas. Yeah, the pressure of the gas inside the container. Yeah, the container can be everything. Yeah, you can say this is a tire. Ya, bisa dalam bentuk ban atau dalam bentuk tabung gitu ya, itu bisa gitu ya. Intinya dia di kontainer gitu ya. Is PO, ya, PO plus rho GH, ya. It's this is the rho of the density of fluid, ya. Density of fluid, and then the G is gravitational acceleration, ya. And then H, yeah, is this one, yeah. How to say, different height of fluid, yeah. Nah, so the total pressure of the gas inside the container equals to the atmosphere or the surrounding pressure, yeah, plus the density of fluid times gravitational force, and then times by the different height of the fluid. Yeah. Okay. Yeah. So I think that's all. Yeah. For our class today. I hope you can understand what I'm explaining to you. And if you have any question, so you can just please ask me. Yeah. Okay. We have still 10 minutes. If you have any questions, so please you can raise your hand up or type your question on the chat box. Yeah. And please don't forget to join the school lagi ya. I'm checking it now, and the member is still okay. There are 1, 2, 3, 4, 5. Yeah, okay. So 5, 1, 2, 3, 4, 5, 6. Yeah, there are 1, 2, 3, 4, 5. Yeah, because I am also using my smartphone here. Okay, so I think no question for today. So thank you for your participation on the first meeting today, and see you on the next week. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
Waalaikumsalam. Thank you, sir.
Yes.
Thanks, sir.
Yeah.
Thank you, sir.